Hello, everyone. Welcome back. So today in class, what we did is we looked at what it means to do a regression. So a regression basically creates a model of whatever data that we have. So what we looked at is we have this data table that compares the year versus the Dow Jones stock price. So we have the year starting at 2015, so this represents 2015, 2016, 2017, 2018, and 2019 versus the stock price. We looked at how we can use Google Sheets to insert a chart, which is our very first step in making the regression. So as a reminder, we highlight the data. I click here, I drag. You can see it highlights. Once I highlight everything, it highlights the whole thing in blue. I can click Insert Chart. And now right off the bat, we have this chart. Now, what it has is, it may start you over here, it may start you over here. Either way, you want to scroll up in this setup. For these purposes, I do not want a line chart. I want a scatter chart. So instead of line chart, click on this one. You'll see that it makes a bunch of dots. I can move this over for ease of reading. And I can see here that my data, 0, 1, 2, 3, 4, versus my y-axis has been graphed. Excellent. Now, what we're going to do with this chart is we're going to click on the Customize tab and then go into this Series option. Inside of Series, we scroll down until we hit this trend line, which we want to have checked. So we check it, and we can see that immediately it creates this trend line. It starts off with linear. You can see it's a straight line. We don't want linear, though. We've been discussing polynomials. So we go to polynomial. You have to tell it what degree it is. Degree, remember, is the highest exponent in the equation. The way that we know what degree it is as follows. We count the number of dots that we have. We have 1, 2, 3, 4, 5 dots. The degree is always 1 less than that. So I have 5, 1 less than that is 4. Okay, this is always going to be the case. However many dots we have, however many data points, our degree polynomial to map it is going to be 1 less than that. So I put 4, I click on my keyboard, enter, and I can see immediately what happened is I've gotten this curve. Pretty cool, huh? It's actually a lot of complicated math that's going on behind the scenes. And the beauty is that Google Sheets does it all for us. What's cool is that there's always going to be an equation, a polynomial equation, that's why they're so powerful, that maps to this data. And that mapping is called a regression. If we want to see what is the actual polynomial, we can click where it says label here, use equation. Use equation, and it pops up with the equation here. Our price, basically this y, is equal to 17,425 minus 7,443x plus 15,842x squared minus 6,975x cubed plus 913x to the fourth. You can see it's in the opposite of standard form, which we don't love, but we accept it because this is what it gives us. Here is all the information that we need. So what can we do with this information? This right now, we've created a model. Now we're going to determine, is this model accurate? Is it useful? Those are the questions we're going to be asking and answering. So whenever I have a model with this equation, I can go into Desmos and graph it. You'll see here that I've already done that. I've inputted the equation carefully, and here's that first equation. So here's my graph. It looks kind of wonky, but we're going to ignore how it looks because all we care about is that it's in here nice and clean. What we're going to do with that information is start to answer some of these questions. So the extension questions is what we're going to look at now. Write down your trend line for your chart here. Well, the trend line is the 17,425. I can just copy and paste that from this thing I wrote in Desmos. It's going to come up a little wonky, but it's okay. I'll know exactly what you mean. You can see here that it copies and pastes it over here. All it is I highlighted copy and pasted it over here. Now, to figure out part B is asking, use your trend line to estimate the stock price in 2020, which is my year 5. Well, the beauty is that I now have an equation. Here's my equation. So instead of putting x here, this long equation, instead of putting x, I can put 5. So wherever I see an x, I'm going to input 5 instead. And that's going to get me the value at the 5th year. If I wanted it at the 6th year, I'd put in 6 for all of these. The beauty of a model is that it makes it really, really, really easy to see what's happening at certain years. So you can see here that the prediction is that it's going to be 75,010. So that's my prediction. I'm going to put it over here, 75,010. Now we might start to think, is the stock price really going to be $75,010 in 2020, which was last year? No, it got nowhere close to that. So you might start to think, well, that seems a little bit odd. We just made this model. The model seemed good. Why isn't it working? Well, it isn't not working, but it isn't giving us the information that we want. How might we make it more accurate? We need more data. We only have a few points of data here. If we had more and more data, it would be more and more accurate. So statisticians like to gather lots and lots and lots of data in order to make the information more useful and more accurate. So do we think that this seems accurate? No, it doesn't seem accurate. And the truth is, and this is what I really want to hammer home, that we can't always count on the model to predict the outcome. We can't always count on it, right? Even if we had more and more data, if it still gave us this wonky answer of 75,000, we might start to think to ourselves, maybe this model isn't accurate. This is something important to think about. Models are used all the time in math, in science, all across the world. They have lots of applications. And the beauty is that it's really easy to see what might happen at a certain point in time. However, it's important that as someone, as an outsider, that you're looking at that model with a little bit of scrutiny, saying, does this actually make sense? So that's what I want to leave you with today. I encourage you to think about naming one benefit and one limitation of using models. And your task is to do the same exact analysis, creating a polynomial regression, answering these same extension questions for yourself. I wish you luck. I look forward to speaking about it with you tomorrow. And remember, these are important questions to be thinking about. How can we use data? How can we use Google Sheets to make our lives easier? And what are the limitations in doing so? See you tomorrow.